Welcome to the other part of connecting our API to the database, and today we're gonna show the database first approach. So let's get to it. So we talked about the code first approach in the previous video, and now we're gonna talk about the database first, where we create all of the tables, models, and relations in the SQL database using SQL queries. And then using that database and this almost the same stuff that we did in the code first, we will install only entity framework package and the designer package that exists, as well as the SQL server package inside the entity framework. Once we install those packages, we can do the and now, before it was two commands, right? It was .NET EF migrations add and .NET EF database update. Now it will be only one command, that is .NET EF DB context scaffold. And how it looks, let me show you here. So if you remember, we talked about this one. So this is from C# models, so C# code class to SQL queries to database. So what we are going to do now is the from database and all of the tables create the C# model classes. So what we're going to do is we're going to navigate to our SQL Server Management Studio, start it up and execute some queries, and then again using entity framework we are going to execute one little command, that is this one. So this will be the command that we use. So again, .NET EF database context scaffold, and then this is the connection string that we had previously in app settings.json. Right now it will be in the command, and then we have using SQL server entity framework core, and we will use the output dash that we will call our folder models. So when we from SQL tables and models, or sorry, from SQL tables, once we execute this, we want to create a models folder and inside put our tables as models. And this -f is for force, so we don't need that. We can run it without that. So this is the only command that we are going to need when we from SQL database want to create models inside of our API application. So let's do that. If we navigate to our SQL Server Management Studio, let's connect, let's go to the database, and let's create, previously we had the game devs, let's create game devs 2, create that one, and then let's open it up, and then let's use this. I will copy paste some code and show it to you. So using the game devs 2 database, we will create the game developers table. As you see, we have the ID that is an integer, and this is a primary key. And here is the part that I talked about in the previous code first, when I had some trouble at the end with the ID. As I said, that why we are not going to provide it is because this is going to happen in the database. It by itself is going to auto increment the ID value. Then we have the name, that is var_char, so characters, and studio name as well, so these are strings. Then we have the technologies table with primary key, identity, and name. And then we have game projects, and game projects, they have a primary key as well. They have a title, genre, then we have a game developer ID, and we have foreign key on that, that is game developer ID, which references game developer ID property, this one. So that's how we build relation with the SQL query. And the same thing for game project technology, that is a joint table between game projects and technologies. We have that game project ID, technology ID, so game project ID, technology ID, where primary key is the mixture of those two, and then we have foreign key that references the respective table. So game project ID references game projects, and technology ID references technologies. So this is the many-to-many join table, and these are our three usual tables, so usual models. So let me execute this one. Commands completed successfully. If I expand, look at the tables, I get all four. Nice. And that's only thing that I needed to do, right? So I don't need to save this. This is okay. If I now go, let's open up maybe a totally new one. Visual Studio. And let's create a totally new project. That is what we have, game devs 2, for example. Everything's the same. Let's create it. Let's get rid of the weather forecast, and let's get rid of the weather forecast controller. So what we need to do is install our dependencies, right? So install the entity framework package as well as the SQL server and the designer. So let's install this as well. So notice how I choose the right version for my project. I'm using .NET 8 in this project, so I'm installing version 8. And as I said, this only is connected to some packages, not all of them. So make sure you read accordingly which type of version you need. And then let's install SQL Server, also 8.0.14, and then the design one, like this. Nice. Everything's installed. Pretty nice. So right now, the only thing that I need, right, is if we go back here, let's go. If I go back here, where are you? Here. Is this command, right? So if I copy this, this will help me from my database table create C# models. So that's what this is going to be used for. So if I go to my development PowerShell and paste the code here, but I'll have a little bit of things to change. So game devs 2 is the database, and I have some strings here. Yes, like that. And let's see, I think I forgot one thing, and it will definitely show up now. And that's the same thing that we did before. No, it actually worked. Nice. So we have a game developer. So as you see here, we got our models folder, and inside of it, I have a game developer, exactly as we had it before, game project, exactly as we had it before, and technology, exactly as we had it before. So this is how we can create database first approach. By using database first approach, we get our classes inside of our API only by using this command. So .NET EF DB context scaffold. That means that it's going to take our tables and all the relations and create our C# models. So, but most important, apart from models, we got the context. And as you see, we got everything inheriting from DB context. And then we have game developers, game projects, and technologies. We have some overrides on configuring, and we have override on model creating. That has some attributes that you can check out and read accordingly what they represent. So now we got, only by using this command .NET EF DB context scaffold, as I said before, so only this one, we got all of the models that we need as well as the app DB context. So somebody would say that database first approach is easier. Yes, but those who understand databases on a deeper level, they know which amount of work it needs in order to create the entire database and know upfront all of the stuff that you are going to use, as well as attributes and different kind of stuff. But as well, you can always update it. You can always update the DB context that you, as well as models that you have by running the command. But it's the same thing as adding migrations. So once we start changing our models, we can also go and code first, change something, and then migrate and implement or update the database. So that's how the flow works, from left to right and from right to left. So code first and database first approaches. So let's continue. Here we got the models as well as DB context, and what did we say that we need to do? That's why I thought I missed it, but that's the step that we need to do now. And that's going to the program.cs, adding this one. And then instead of this, we are using game devs to context. So I'm adding the service that is the database into my dependency injection container. So that is the service that I use. Database is an external service. So I need to say that in order for me to start using it properly inside my API, I need to register it as a service here. So that's what I write here. And if I want, I can do the connection string that we had here. So if I, maybe instead of default connection, let's write that this is Nemo DB connection 2. And then let's take this, go to app settings.json, and then let's create connection strings, this one, and it will have the value of this that we have, and that will be this, like this, game devs 2. Nice. So now I have registered my game devs 2 DB context, so database settings for my game devs 2 database that we have here. This is the one. So now I can do exactly the same thing as I did before in the code first. I can add a controller that I can do the entity framework scaffolding with. So I add this one. I choose a game developer. I can choose the context class and what the name of the controller will be. I can click on add and then it will generate the entire controller with create, read, update, delete. So get by ID, create a developer, update a developer, and delete a developer, all with connection to the actual database. So here it is, and it works exactly the same way. But let me show you what I've talked about before. It's this part. So if I run it, you can see that we get this one. So we get all of the create, read, update, deletes, right? But what I wanted to talk to you about was this. So we had an issue with this the last time, right? And it's not actually an issue. It's something that, as I said, once we start working on clean architecture and introducing DTOs and other stuff, it will be a lot less complex. But here we have the entire game developer model, right? So it's only these 3 parts, but as well, because each game developer, we said that they can have one-to-many relation with projects, game projects. We get the game projects array as well, and inside of that we have technologies. So each game project has technologies, and then we need to populate that as well. And that directly corresponds to how the models are built, right? So ID, name, and studio name. Then we have the list, exactly as we have it here. So ID, name, studio name. Then we have projects, and projects in itself, they have these 4 attributes, and then we have developer and technologies that is again a list that has in itself ID and name, and that's this stuff, ID and name. So instead of providing everything as we do here, especially with the ID, because we know now when we created with SQL queries that our identity or our our ID is going to be auto incremented, so created on its own once we start populating the database, creating new stuff. The ID is not needed, as well as this stuff is not needed as well once we start creating developers, right? Because even if we have that relation, we have the table that we can use, join table, in order to register this kind of stuff. But as well, instead of providing everything, we provide only the specific parts. For example, name and studio name. So developer name and studio name. And then once we have a developer or a game developer, we can then have different methods and different endpoints for creating or adding. Let's say we create a game project, and then we can add a relation from the game project that it actually belongs to our game developer. Same thing for technologies. So when we start breaking it apart, the entire relation, and of course our program, because if you think logically, when you create something, if we start by creating a developer, we don't want to create everything else, right? We only want to create developer, and then we can create game projects, and at the end we can say which technologies or create new technologies, right? And then we can put everything together. So that's why we are going to talk about it much more once we start with clean architecture and DTOs, so data transfer objects. So instead, again, of providing the entire model as well as the relations, we only provide the stuff that we need in order to create. So if we look here, if we want to create a game developer, what do we only need? We need name and studio name. That's how the table is structured. So the only thing we need is name, studio name. ID will be auto-generated with the auto increment of 1. So that's what I'm talking about. And that we will talk about once we start clean architecture and DTOs and much more. So this was the database first approach. See you in the next one.